I'm showing the outline of my poster presentation titled The Heat Evolution in Hydrogen Deuterium Desorption with Palladium Foil Coated with the Metal Membrane. Okay, so this is the background of the study. The excess heat has been observed in these studies. In these studies using the non-composite particles and the non-sized material composites such as the palladium nickel and the nickel copper and gold palladium silicon oxide, for example. So from these studies, the following conditions are important for inducing a reaction as the source of excess heat generation. One is metal complex, that is composite particles, materials, and the other is the nanostructures, that is nano-sized particles and the thin membrane. So concerning these, we have conducted hydrogen deuterium desorption experiment using the palladium foil coated with the thin metal membrane, where actually we have tried various metal combination as shown here, but in this presentation, we focus on the palladium nickel sample that gave the most characteristic results. And in the sample, there is a fine structure at the interface of the binary metals. So using these samples, we have conducted the experiment, deuterium hydrogen desorption experiment, and examined thermal and hydrogen deuterium diffusion behavior. So with this study, we are trying to confirm the excess heat and its quantitative evaluation, and we have been trying to specify the conditions for reducing the phenomena and clarifying the mechanism. So this is the experiment and the sample preparation. The fine structure was formed on the surface of the palladium foil with a thickness of the 0.1 millimeter by 18 with an argon ion beam, and deposited membrane onto the edged surface by the argon sputtering. The thickness of the membrane is about 100 nanometer. So this is a sample we have fabricated, we have used in the study. And the deuterium loading, the sample was exposed to the 0.5 megapascal hydrogen deuterium gas for 24 hours, and the average loading ratio was about 0.7. And the deuterium desorption, the sample was set into the chamber, then it was evacuated to the 10 to the minus 4 Pascal, and the constant current was supplied to the sample to stimulate the hydrogen deuterium desorption by the Joule heating, and the sample temperature was monitored by a thermocouple and an infrared thermometer, and the pressure in the chamber, the voltage current applied to the sample were also monitored. So this is a experimental setup. So this is the result. These are the typical two results of the hydrogen and deuterium experiment. So in this plot, and orange showed the temperature measured by the thermocouple, and red showed the temperature measured by the infrared thermometer, and this green dots show the voltage applied to the sample, and this blue dots show the pressure in the chamber. And the time variation of these were shown in these plots. So now we can see the heat generation and gas desorption were observed intermittently during the first few hours of the experiment. And this phenomenon was observed both in the hydrogen deuterium experiment and with high reproducibility. And also we can see that the pressure and the voltage change appear to be synchronized. This indicated that the sample resistance increased when desorption. So now you can see this figure. And well, so we can imagine that the loaded hydrogen deuterium moved to the sample surface, and it is locally densified. Then it was dissolved from the sample when the density exceeds a certain level. So this is a possible model. And we have estimated the unknown excess heat by calculation of the heat balance, considering the heat quantity derived from temperature change and the electric power applied. This is the input power. And now we found about 0.1 joule. This is a maximum instantaneous value. It was generated simultaneously with the large amount of hydrogen released. But there is still considerable uncertainties in the estimation. So we should improve this calculation, model calculation method in the next step. Okay, finally, this is a summary and outlook. We have performed the hydrogen deuterium desorption experiment using the palladium foil coated with the metal membrane, especially here the palladium nickel, and we found a short period fluctuation of temperature and the simultaneous increase of temperature and the voltage, and heat generated from an unknown source, where it's kind of excess heat, is about a few hundred millijoule. So we still need to improve the method to evaluate the excess heat with higher accuracy, and systematic study with the various types of sample and experimental conditions may lead us to clarify a trigger condition for inducing anomalous phenomena. That's all. Thank you.